So we received samples from the Apollo 17 mission, which were returned to Earth in December of 1972, so nearly 50 years ago.
Basically collected on the moon, brought back, then they were frozen within about a month of being returned, so no one's ever looked at them since. It's very exciting.
A curation facility at NASA Johnson Space Center sent us the samples, and they did have to do some special efforts to keep them cold because we wanted them to stay frozen. So they had a special cold shipping box with panels that were frozen in a very cold freezer and a chunk of dry ice. We picked it up from the receiving office here at Goddard, opened it up, pulled the samples out, and stuck them straight in our freezer and locked them up safely.
So these frozen samples were actually collected from a region on the moon that was in shadow from the sun. So it was basically a large boulder. In the near future, we're going back to the moon and hopefully going to the polar regions of the moon, where some of these regions are in permanent shadow and they don't see the sun, they're cold. These particular samples are really great analogs for what we might expect to see in the polar regions when we go back.
So we actually started last week to process the samples. So the samples we got are basically dirt, lunar dirt, and we basically made moon tea out of them. So moon tea is what we call it when we pull out the soluble compounds from the soil. And so we basically take the lunar sample, seal it up with a torch in a little glass test tube full of water, stick it in an oven overnight and boil it, and we're just pulling out those soluble compounds that we care about, the same way you'd make tea with boiling water at home.
What we're trying to do is answer some questions about the history this sample experienced at the surface of the moon. The surface of the moon is a really hostile environment. It's not like here on Earth where we have this beautiful atmosphere that protects us from the nasties of space. So we have particles from the sun that are continuously hitting the surface of the moon, and we've got galactic cosmic rays that are coming in and penetrating into the surface as well. So they actually create noble gases in these particles. So you can imagine that there's none to begin with, and then as they get exposed to this space environment, they kind of get more and more buildup of noble gases. And our technique is to actually unlock those noble gases from the sample and measure them so we can come up with what we call a cosmic ray exposure age. So it's basically how long this sample has been sat at the surface, being exposed, so basically getting a space tan. Say 50 years ago, this same technique, which is called noble gas mass spectrometry, would probably need anywhere, tens to hundreds of milligrams to do the same thing that we now do with a couple milligrams.
It's really special to be part of this, and particularly because I can look back at the papers and the processes that the curation office and the scientists in the 1970s thought about, and they put so much care into preserving these samples for future science, to making sure that they were going to be at the best conditions, so that as we develop new techniques, we're able to go and look at these samples and get new answers to the science questions that were being asked.
I'm still studying these samples 50 years later from the Apollo mission, the original Apollo missions. And, you don't know what's going to be in another 50 years, but I'm still a part of the Apollo dream of going to the moon and bringing samples back. So the fact that we have Artemis now is amazing. Like, having our own Artemis generation is really exciting. I just can't wait to see people go back to the moon.